How do we get actually electromagnetic radiation? A charged particle like electron or whatever, negatively charged particle, electron. Of course, you know that a charged particle that is accelerated radiates electromagnetic radiation. That's how actually we get radiation. Wave number k we represent with k. Wave number k is equal to 1 by lambda. Electron is a point particle. See, you can see electron movement. This is particle, one small dot that is moving in this direction. That means it is taking this path, wave. It's moving like a wave. Here, from here to here, it is delta x. Okay, and its amplitude. You know what is amplitude? Okay, h is equal to 6.63 into 10 power minus 34 joules second. H is actually, in terms of electron volts, we write 4.14 into 10 power minus 15 electron volts second. The smallest amount of energy a light wave of frequency f can have is hf. Okay, a light wave can have the smallest amount of energy, okay, of a frequency f can have is hf, the energy of single photon. Okay, that is the energy of a single photon. Atoms are usually excited or ionized by bombarding them with electrons accelerated through a potential. Okay, atoms are usually excited or ionized by bombarding, that means by hitting with them with electrons accelerated through a potential. When accelerated electrons, when they hit the atoms, then usually they get excited or ionized. It is not possible, according to Heisenberg, according to him, he says that it is not possible to measure simultaneously the position and the momentum of a particle with unlimited precision. Okay, that means uncertainty will be, that means error will come actually while we try to measure. Delta x into delta p is greater than or equal to h by 2 pi. Energy and time coordinate of a particle, already we have discussed, delta E into delta T is greater than or equal to h by 2 pi. Similarly, delta J into delta theta is also greater than or equal to h by 2 pi. A more rigorous derivation gives h by 4 pi in place of h by 2 pi in the above equations. As you go higher standards, instead of h by 2 pi in your intermediate level, you must have studied that it is h by 2 pi. Actually, it's a rigorous derivation that gives us, it's more accurate to say that delta E into delta T is greater than or equal to h by 4 pi. Okay, in the above equation. However, the difference has no practical consequences for our discussion. So, it's not a problem at all. Fine, what we are discussing is on what matter waves, right? Sound waves and waves on strings are described by equations of Newtonian mechanics. That means classical mechanics. Light waves are described by Maxwell equations. Matter waves are described by Schrodinger equation. So that is the importance of Schrodinger's equation. The behavior of material particles, okay, we usually represent it with Schrodinger's equation. Mechanical energy in the sense potential energy plus kinetic energy of a moving particle. When light interacts with matter, energy and momentum are transferred via photons. Okay, when light interacts with matter, what will happen? Energy and momentum are transferred via photons. What are matter waves? We already discussed several times that a moving particle such as an electron or proton can be described as a matter wave. Matter wave. Subatomic particles are matter waves only. Its wavelength, called de Broglie wavelength, is given by lambda is equal to h by p. P in the sense mass into velocity. Lambda is equal to h by p, where p is magnitude of the particle's momentum. Quanta are photons. We are all discussing again and again this what are photons, what are light waves, what are actually matter waves. Okay, quanta, photons. An electromagnetic wave, light is quantized. And its quanta are called photons. Its quanta are called photons. I already told you, if you have a 100 rupee note, a quantum of this money is actually 1 rupee. That is actually 1 rupee is building block of 100 rupees. So here, same way here, an electromagnetic wave, which is actually light, what we are talking about is, an electromagnetic wave, light is quantized and its quanta are called photons. Classical mechanics fails to explain the microscopic system of particles due to uncertainty principle. Okay, thus it can provide correct explanation for the behavior of macroscopic system. According to uncertainty principle, the position and momentum of a particle cannot be measured accurately at the same time. The measurement of one quantity introduces an uncertainty into the other. Okay, quantum mechanics, which assumes both to have definite values at all instants, is not valid for atomic systems. Classical mechanics could have explained, but why it is failing? Because of the uncertainty in one parameter. Because of the uncertainty in the one parameter. Just wait. An electromagnetic wave, light is quantized and its quanta are called photons. Classical mechanics fails to explain the microscopic system of particles due to uncertainty principle. Thus, classical mechanics provides correct explanation for the behavior of macroscopic system. According to uncertainty principle, the position and momentum of a particle cannot be measured accurately at the same time. The measurement of one quantity introduces an uncertainty into the other. Classical mechanics, which assumes both to have definite values at all instants, it is not valid for atomic systems, because classical mechanics, if at all you want to get some parameter, you need to have definite values for all the instants. That's why classical mechanics could not explain this microscopic particles behavior. Okay, so Bohr's model, a classical atomic model to explain the behavior of atomic system. This is called Bohr's model. This is the classical atomic model to explain the behavior of atomic system. According to de Broglie theory, a material particle is associated with a wave. Quantum mechanics was developed in 1926 by Schrödinger. He described the amplitude of matter waves by the complex quantity psi of x, y, z, t, known as wave function or state of the system. It describes the particular dynamical system under observation. Okay, I already told you that quantum mechanics, it is developed by Schrödinger. Schrödinger wave equation explains the material particles behavior. So wave function, a matter wave is described by its wave function, usually psi of x, y, z, t. It's a function of x, y, z and t, which can be separated into space dependent part psi of x, y, z and a time dependent part e power minus I omega t. Schrödinger equation dou square psi by dou x square plus 8 pi square m by h square into e minus v of x into psi is equal to 0. This is called Schrödinger's equation. We'll be deriving it. Okay. According to de Broglie, it's less than 1 minute. Probably it closes. Anyhow, we'll see. According to de Broglie theory, a particle of mass m is always associated with a wave whose wavelength is given by lambda is equal to h